All right, guys. So as promised, here's the video that I'm giving you guys. Let me just tell you right here that this is where you're gonna go. Ooh, try that one more time. Draw. This is where you're gonna go. You're gonna go on the Canvas page and you're gonna go to this link right here, and then you're going to clear drawing. Oop, mouse. Click on there, and then this is gonna pop up like this. All right, so again, today's learning targets. I'll learn to write quadratic functions to model contexts. I will learn to interpret key features of quadratic functions in terms of a context. We kind of did that with the remember the pennies? Yep. And I'll learn to identify domain and range of quadratic functions in their text. We did the domain and range for the linear stuff. We did not yet do it for the quadratic. So we're going to be working on these last two right now to finish it up. All right, and as I said before, here are the vocabulary. I'm only going to do this once, maybe for those of you guys who are watching this video. Here's Angry Birds because it's Angry Birds in vertical motion, right? And then roots. And here we go. So for the self-paced Nearpod, that's here. So the Nearpod that we did today. So for those of you guys who do not have a book, you have not logged into Mathia yet, although it's in your Mathia. The book is in there, ebook, if you would say. And so right here, this is going to be where that work is that we did not finish. Okay, so I like to click on this preview button. If you want to download it to your laptop or phone or whatever, you can do that here. You just click on it and out will pop up this right here. It'll just download it for you. I don't like doing it that way. I like using this magnifying glass and it'll just pop up, boop, just like that. All right, so I took a picture of mine and I used this application or this app called Cam Scanner. If you need to take pictures of your work and then submit it in at some point, like for a quiz or something like that, that's what we will do. Okay, so we talked about this. Remember, this was the dog. And this is the storage. This is how much this is the storage unit right here. And we got to, let's see here, for the most part, we got to this. And again, if you did not get to this part, you were not paying attention, I don't know, whatever. Just take a look at it again, re-look at it. I try to make things with color, I don't know, we'll see. And then, so this was our line, remember? And we said it was decreasing. For some classes, I don't know if I got to the decreasing and the x-intercept part, but remember we're going from left to right, always going from left to right. So this is decreasing. If it was going up like this, so if it was going in this upward direction like that, that would be increasing. This is decreasing, all right? And let's see here, and our x-intercept right here, that's where the the axis and the x-axis and the line meet. So that's gonna be your x-intercept, or as I like to say, x-int. And then this would be for page 9, and we actually do have to go to page 11. I know, yay, happy days. But we do need to go to page 11. So here, so this was going to be the area. So we didn't really get to this part right here. So let's see if we can use my pen here and my drawing. Okay, so as you can see here, our A of S right here is going to be, is to represent the area. So remember, area is like length times width. So this is like our length, this is our width right here. So this is length, this is width. Honestly, order does not matter. This S, usually in math, we would see that like those, like the monomial just be in front. We don't usually see it in the back, but that's fine. That's okay. If you wrote it like that already, if you wrote S and then 100 minus 2S, that's fine too. Okay, either way is okay because it's multiplication, so you can like switch them around. Okay, and over here, so and describe the area of the enclosure changes. Oh, how the area of the enclosure changes as the side length increases. So like we said in some of the classes, but you guys could take a look. Let me scroll down. So as you can see, it's small, then it seems like it's getting bigger and bigger and bigger. Then all of a sudden at some point, it looks like it's getting smaller. And if you can imagine these dotted lines getting like increasing and bigger, that all of a sudden you're not gonna have any enclosure. You're just gonna have two storage units, 50 and 50, right? 50 feet, no enclosure, straight line, all right? So that would be a poor dog, sad dog. All right, so what would that look like? Predict what that would look like. Oh, I had said the area gets bigger then smaller. So I'm thinking it's, if I show you with my finger, you're not gonna see that. So it's getting bigger and smaller. So I'm assuming that this is what it's gonna look like, something like this. And we're going to use technology here. So it says to use technology. And so for those guys who do not have a graphing calculator, you don't want to download it, or maybe you don't have enough space. I'm going to give you the benefit of the doubt. You don't have enough space on your phone. That sometimes happens. You are going to go over to, for you guys, all you guys see are like 3 things. I'm in teacher view right now, so I see a lot of different things. You go to modules, you'll see modules, okay? And then you scroll down, there's like a whole bunch of different things on here. And do you see the one called tools? And then you're gonna see the Desmos calculator. I already embedded it for you, so you can just use this one. And so Desmos calculator, you gotta wait just a little bit. So in here, this is where you put in type in your equation. So technically you don't need to put y equals, but I'll put it in. Instead of A of S, we're gonna put just y because they don't have like that other thing. And then you're gonna type in, what was it? 100, so parentheses 100 minus 2x in parentheses, times x, just like that. And you'll notice the straight line. It looks kind of like a straight line. For those guys who do not have a keyboard and you're using like your phone, remember there's this, if you show the keypad, you can just do it on here and just type this, put it this way. Okay, so then what you're gonna do, this is obviously too small. Well, you do know that the x-intercept, one of the x-intercepts right here. We're gonna scroll out. If you have one of those on your phone, that's why it's easier on your phone. Actually, I have a touch screen, yay. So you can kind of figure out where that is. So if you can see, it looks like a very steep U or an upside down U like this, looks like this, but it's not pointy, it's actually round, okay? So if you go in enough, but if what you wanna do is you wanna put your mouse over there and you just point to it, and a dot will appear and it does like major like features. Like this is one of the key features that we're gonna talk about. So this is the highest point is gonna be 25, 120, 150, or 1250. Okay, it's 25, 1250, remember that, okay, because we're gonna use that. Another one we're gonna use, we're gonna go down here. I wanna see where it ends up because it does cross the x-axis again. I'm just gonna, 50, 0. Okay, so that's where that's gonna be, okay? So these points are like key feature points. So think about them. Remember we talked about our learner targets. And so on your paper, you're just gonna draw like a parabola. It doesn't have to be, don't make it this tall because that's too much, right? So we're gonna make one that looks like this and we're just gonna write down the key features on there. So if you don't have a calculator, use this on Canvas. I put it for you there. Okay, now I'm gonna go back to, yes, and Desmos always says, leave site, changes you may not be saved, don't worry about it. It's cool. It won't save it, but you don't need it to save it. Actually, maybe you do, but it's okay. I'm gonna go back to, so for those guys who want to just look at the modules, you would just go back to week 2, because this is a week 2 now. Go to Monday. You could also find it this way. All right, scrolling down again. Okay, going back, scroll down some more. All right, so we were already there. Here, this is what we were gonna do. So as you can see there, I kind of drew it. I was trying to be very specific because that's the kind of student I am. I just make these very, try to make it be as accurate as I can. I couldn't do that in class because there wasn't a lot of time, so sorry. So this one right here, you're just marking them. I just went by 200s because that was the, that's where I could get to 2000, I could get to 1250. So here it is, 1250 right here. There's my 2 marks right there of where it crossed the x-axis, and there we go. I'm sorry you can't see that very well. That was supposed to, well, you will go back to labeling. It didn't say to label it yet, but just make sure you check on your graph. Did you write down this right here? Because it says also to label the axes. So write down side length of the enclosure in feet. So you always do that. Whenever you do graphs that are in context, you need to have some kind of label, okay? So make sure, I don't want you to get docked for that because that's a thing, right? And over here, this is the area of the enclosure, okay? Not the, I had length of, and then I was like, oh shoot, that's the wrong one, okay? And remember, this is always what the X represents. This is what the Y represents, okay? And when I say Y, I mean A of S in this case. Okay, so we use technology, we sketched the graph, we labeled the axes. Yep, done. All right, it says describe what all the points on the graph represent. So all these points, and I just wrote down how big the area of the enclosure is given the side length. So if you know the side length, we're gonna be able to find out what that area is. Okay, so if it's at 10, sorry, this is not really accurate, so don't quote me that it's 800, but it would be whatever this point is actually, because I just sketched it. I wasn't accurate on every point, but if you go on Desmos, right, and every point you have on there, that would be accurate. Okay, this is just a sketch. Okay, so we're going to go to the next page because we're not done yet, because remember page 11. So the function a of s that you wrote to model the area is a quadratic function. Wah! The shape that a quadratic function forms when graphed is called a parabola. So this dude right here, this doohickey right here, okay, that's not even better. This is called a parabola. So any like round shape like this, that is a parabola, okay? And it could be a little bit skinnier, as you could see in Desmos, or it could be wider. It comes in a wide range of forms, but it's always going to be like this U thing. And sometimes you may wonder, is it always this way, or is it sometimes this way? Well, we shall find out tomorrow. So we're going to go, so quadratic function, parabola. So parabola, that was one of our words for today. And here we go. So is there a maximum area of the enclosure that the enclosure can contain? There must be a maximum area, because remember, it got bigger and then it got smaller. So at some point there's a maximum, a biggest area, right? And so explain your reasoning in terms of the graph and in terms of the context. Okay, so now if you have not done this already, I would go and do the rest. I would pause this and then answer the rest of them. If you have not, if you've already done and you want to just check it, then just check it. If you're confused about some parts, then you can just tell me. And so what we're going to do here, so in terms of the context, you can see right here, look, oh, maximum. This is as high as the graph goes, right? So that point, which I didn't draw very well, that point is going to be the maximum, okay? And right here, and in terms of the context, so when the side length, so I just took the points on there, when the side length is 25 feet, side length of the storage area, the area is going to be 1250 feet squared, because remember, we're talking about area, so it is going to be square units. And I thought this was kind of cool. If you do think about quadratic function quadratic functions model area, because the area is measured in square units, right? Square footage, we're talking about like houses or apartments, we're talking about square footage, like how many of these square feet fit in, right? If you're going to stack them all, lay them all next to each other, how many of those fit in there? That's how you can tell how big a house is, right? So, and it says again, use technology to determine the maximum of A of S, which we already did, right? Remember, I told you to remember those numbers. So we have 25 here and 1250 here. So this is going to be our S and our A of S, or we think about X and this is Y, okay? And I just labeled these here. Just so you can see. So describe what the x coordinates of the maximum represent. I kind of already did that up here. So this part should have actually been down here. Sorry. Okay, so you can do that right yourself. And then it says for C, determine the dimensions of the enclosure that will provide the maximum area, and show your work and explain. So I'm going to figure out what that is. If I know that this is going to be 25, because that's our side length, right? Then that means that this part right here, I have to do a little bit of calculation. We already know that equation, right? Is 100 minus 2x, or 2s. And we know that s is 25, so we're just plugging that in, kind of like how we did for our warm-up today. And we get 100 minus 50, which would just be 50. And that's how we got 50. That's the dimensions, okay? And just to check my work, I just go 25 times 50. Or yeah, 25 times 50. And I get 120, and I get 1250. Good. I thought I did that wrong. Also, and then now we're going to talk about domain. Okay, so now if you look at the domain, remember this is in context, so very much like our line for the previous one. For our line, this goes from 0 for the domain is talking about our x. So remember, I'm going to just put it here really quick. Let me draw. So remember we had our draw. Okay, there we go. So remember we had our x-axis here, our y-axis here. Pretend this is so straight, okay? We started like this. And this, remember, this went up to 50. That's a terrible 50. And then, and then this was 0 right here, and then it went up to, this was right here, 1250. Okay, so knowing that, so for the domain, we're talking about from here to here. So let's see if I can do a little thicker one with a different color. Okay, so from here to here, hey, come on, work with me. Nope, doesn't want to work with me. Oh, there you go. So the smallest that it could be to the biggest that it could be. So it's from 0 to 50, right? So that's why I put over here from 0. So 0 is less than or equal to s, which is less than or equal to 50. Okay, so that's what we're doing here. And then, so that's the domain for our context. So this is, again, in context. So this is our domain. Okay, that's our domain. And then we're going to go for our range, and we're going to make that purple. And so here, remember the smallest that it's going to be and all the way to how high it's going to be. So that's going to be from 0 to 1250. Okay, so that's what we did here for our range, 0 to 1250. Okay, and please make sure this is all, we will always put the smallest one here and the biggest number here. We're going to go less than or equal to. It's always less than or equal to. Okay. I mean, granted, if you did a greater than equal to and flipped the numbers, you're not wrong, but it's just not standard practice. You know, we don't say, oh, you have to be from the ages of 18 to 12. We say 12 to 18, not 18 to 12. It's not wrong, it's just not what we traditionally do. All right, moving on. Now we're going to talk about the domain of the function. So now this function, you may not know, actually continues. So it goes up like this. And if you were to look at Desmos, it continues on down. If I can write it like, oh, come on. It goes down like this, and it goes down like this, like forever and ever down this way. So for the function, the domain, so the x can be anything. There's no limit to what x can be. So x can be anything. So like we said before in class, so it's going from negative infinity to positive infinity. Okay, and that's going to be what our s is. Right? And for our range, that's going to be, there is the highest it can be. So it can go, let me use a different color here, and go from this right here, 1250, all the way down. Notice it can go all the way down, keep on going down, right? So you can get as small as it wants, but we just can't go any higher than 1250 because that's the maximum that it can be, right? So that's why I said A of S is less than or equal to 1250. So because it can equal 1250, that's why I have the equal sign. It just can, it's going to be less than or equal to, okay? And like I said before, with the infinity signs, we can technically never reach infinity. If you do, then you're not there. That's not infinity. So that's why we never put equal signs when we deal with infinity. Okay. So this drawing is going to go away. So if you need it, take a picture of it. And so I'm going to clear this guy because I need to go down to the next parts. We are almost done, guys. Almost done. Okay. So sorry about this little mess here. Little things went on. All right, so identify the key characteristics of the graph, then interpret the meaning of each in terms of the context. So if you see right here, so the y-intercept we talked about, remember the little graph, I'll draw it again. Boom, boom. Oh, look at that. So the y-intercept is right here, which happens to be also the x-intercept as well, right? Because it crosses right at the origin. So the y-intercept, and if you're dealing with functions, you only have one y-intercept. You never have two, because if you have two, it's not a function anymore. Okay. So 0, 0. So basically, we're writing this in context. So if the side length is 0, then the area is 0. That makes sense. If there's no length, right, there can't be any area. So, and again, right here, so we go to B, when is the increasing, decreasing? Remember, we go left to right. So I'm going to use this color. So if we're going, and we're going left. So we're going up. Oh, look, it's increasing this way, right? And all of a sudden it stops and then it decreases, right? So increasing is going to be here. I use interval notation here. If you want to look that up, go look it up. It looks very similar to coordinate points, but this is just interval notation. So if you see here, this is 0 is less than, okay, not equal to, because at 0, it's actually not increasing or decreasing, it's just 0. Well, it's not an inflection. Okay, you know what? It's probably equal to, but I'm sorry about that. So is less than or equal to S. Well, technically it does stop there. So we're just going to say at 0, it's not going to increase. We're just going to do the less than symbol. Is less than S, which is less than 25. Because at 25, it actually is a flat line. It doesn't increase or decrease at that point. So we're not going to include that. Okay, 25. I'm sorry for my mess here. So here again, this is interval notation. We're not going to really use it that much. So this is going to be 25. So it's decreasing now from 25 all the way to 50. And notice when we talk about those, we're not talking about the y. We're just talking about the x. Okay, so we're looking at just the x part. If you remember right here, come on, draw for me. Right here, this part right here, remember that was in line with that the highest point there. So this one is going to be this. Let me change the color so you can see it. So remember this point was 25, 12, 50. So this is going to be right here at 25 because we're looking at just the x part. Here's 50 and here's 0. Okay, so there's the 25. That's where the 25 is coming from. So 25 to 50, that's where it starts decreasing. Okay, and so we're saying the area decreases when the side lengths are from 25 to 50, or are greater than, I should say, are greater than 25 feet to 50 feet. Okay, and then we're going to go symmetry. There is, oh, I actually just draw it. So see this purple line right here? That is our symmetry. Remember geometry? It talks about symmetry, like it's the same. So if we were to fold it over, it would be the exact same on this side and this side. So parabolas, they are symmetrical. And this axis actually has a special name to it. You know what we call this? You'll learn about it soon. But it's called the axis of symmetry. I know, so creative. Okay, so if you want to label that in your book, go for it. I usually refer to this as AOS because axis of symmetry is a lot of syllables, right? Axis of symmetry, so that's 6 syllables. Instead of, and I just usually call it AOS, which is 3 syllables. All right, cut it in half. So if I say AOS, I'm talking about axis of symmetry. Let's see here. Oh, also the x-intercepts, we have this many, right? We have, let me change the colors here. Let's make it maroon. So there's one right here, x-intercept right here. So that's going to be, yeah, so I have 0, 0 here and then 50, 0 here. So again, I explain it right here. If the side length is 0 feet, then the area is 0 feet squared. That makes sense. There's no length, there's no area. So if the side length is 50 feet, right? So I drew a picture because I thought it might be confusing. So if this is 50 feet right here, which means that the other storage unit is 50 feet, which means that's a total of 100 feet, which means where's the enclosure? Dog gets nowhere to run except for a fence that's running down the line. It's like this. So if I ask you, what's the area of this part right here? You'd be like, honestly, there's no area. The dog cannot walk on that fence. Unless you do have a dog that walks on your fence, and you guys can go to AGT. I will vote for you. All right, so so there's no enclosure here, and I wrote down, that's what I wrote down, no enclosure. All right, so that is the end of the lesson. If you need to go back and review it, go back and review it and all that kind of stuff. Please make sure you're working in math yet, because that's going in line with what we're doing here in class, and it's just to help you guys out because we don't got much time, people. All right, so I'll talk to you guys later. See you tomorrow. Bye.